All right, here we are, lesson 9.2. Finally, it seemed like a long time coming, didn't it? We're going to be solving quadratic equations by graphing. So we're going to solve by graphing. We're going to approximate the zeros of functions and possibly do some real life examples. Step one. First thing you want to make sure is that you have it in standard form. So you'll have your trinomial, ax squared plus bx plus c equal to 0. So if you have anything other than 0, you might need to, add or subtract, get all the terms, all three terms, a, b, and c on one side of the equation. Step two, we want to graph it. So we want to graph it as y is equal to, ax squared plus bx plus c. Then we're going to find the intercepts, the x-intercepts. These are places where it's crossing the x-axis. And, if there's any, there might not be any. So the solutions or roots of this trinomial are the x-intercepts of the graph. So let's take a look at this. So the first thing we can see is that we need to first make sure that we have, so we'd be subtracting 3 on both sides. Okay, so that we get this right here. And then we want to graph it. So you have options for graphing, right? You can make a table of values. You could have your x and your y, and you can do five or 6 points, maybe -2, -1, and so on. Or you could do the negative b over 2a, and this is going to give you the x coordinate of your axis of symmetry and vertex. Plug that in to find y to get the vertex. Use the right here. We know that that's where it's crossing the y-axis, and then you have the mirror image here. So if you have the vertex, so then you might need to plug in and do a few other items there, but you're going to want to graph that as best you can or approximate what those values are. What you're looking for is right here, the place where y is equal to 0, okay? So you want to find x when y is equal to 0. And in this case, it's -3 and 1. So your solutions are x is equal to -3 and x is equal to 1. All right. So let's get started. I think it's going to be easy. Let's see. We have x squared plus 4x. There is no c, but c could be 0 in this case. And if that's the case, then we know already that it's crossing right here, the y-axis at 0. So let's do the negative b over 2a to find the x-coordinate of the vertex. So we'll have -4 over 2 times 1. So -2 would be the x-coordinate. Then we could plug this in and get -2 squared plus 4 times -2. This will be equal to y, the y-coordinate. So we'll have 4 and then -8. So we'll have -4 is equal to y. So our vertex is at -2, comma, -4, right? So -2, 1, 2, 3, 4. This is also the axis of symmetry right here. So if you recall, there's the y-intercept that we determined because we kind of have this, x squared plus 4x plus nothing, and there's nothing to rearrange and put in there, so it's 0. And then we know that that's 2 away from the axis of symmetry, so 2 away from the axis of symmetry here. And then this is our parabola. Ooh, boy, me in drawing these. And these are our solutions, the places where they cross the x-axis. So x is equal to -4, x is equal to 0. So that's our solutions. So here, I could add this and subtract that, but I think I could just easily add this because I don't want it to be negative anyway. So I'm adding x squared on both sides. So I'll get x squared is equal to -2x plus 1, and because of that, it would be equal to 0. So that's what we need. So our negative b over 2a would give us, I just rewrote this even. I don't know. All right, so I added this to both sides. So I was supposed to just put it in there. I don't know why I rewrote the equal sign. So x squared minus 2x plus 1 would give us, so the opposite of b, right, would give us a positive 2. So I'm going to go ahead and deal with that negative right now. And then 2 times 1 is 2, so we have a positive 1. So the x-coordinate is a positive 1. So y is equal to x squared minus 2x plus 1. We'll substitute in 1. So we get 1 squared minus 2 times 1 plus 1. So 1 minus 2 plus 1 gives us y. And in this case, 1 minus 2 is going to be negative 1. Negative 1 is 0. So we have a vertex of 1, 0. So here's our vertex right here, right? We can see what c is equal to. That's what's crossing the y-axis, positive 1. With this being our vertex, this is the axis of symmetry. Therefore, we have another point right here. So when we draw this and then examine, where is this crossing the x-axis? What are our solutions, or what is our solution? In this case, we have one solution. X is equal to 1. Okay, here we had 2 because we had 2 places it was crossing. All right, so number 3. It's already in the right form. I don't have to do anything like that, so I can do my negative b over 2a. In this case, I want negative 2 over 2 times 1, 2, so it's going to be negative 1. So then I'll put in negative 1 squared plus 2 times negative 1 plus 4 will be equal to y. 1 minus 2 plus 4. So 1 minus 2 is negative 1. Negative 1 plus 4 is 3. So I have negative 1 comma 3 as my vertex. So negative 1, 1, 2, 3. All right. My y-intercept is 4. C is always the y-intercept. So starting from 0, 1, 2, 3, 4. Oops. And then we know that we have, the mirror image because of the axis of symmetry. So my parabola is going to open up right in my work, right in the way. But where is it crossing x? Do you see any place where it crosses x? It does not cross x. So there is no solutions in this one. Okay, no solution if it does not cross x. So it could cross it in 2 places, it could cross it in 1 place, or no solution at all. So just to summarize, we have the number of solutions of a quadratic. You get 2 real solutions when the graph and its related function has 2 x-intercepts, like right here and right here. This is an example of 2 real solutions. Okay, you get 1 solution when the vertex is basically on the x-axis. One real solution in this graph. And then you get no real solutions when it doesn't cross it at all. It doesn't cross the x-axis. There are no x-intercepts and no real solutions.